Hello, everybody. Alright, so as we all may know, traveling to space is extremely dangerous. And personally, I don't really think it's that necessary. One of the main reasons why we shouldn't travel to space is because the negative effects on the human body. Transitioning from one gravity field to another is trickier than it sounds. It affects your orientation, head-eye, and hand-eye coordination, balance, locomotion, and you're likely to experience a lot of motion sickness. So why would we put our bodies into something like that? NASA has learned that without gravity working on your body, your bones lose minerals, with density dropping at over 1% per month. By comparison, the rate of your bones lost for elderly men and women on Earth is 1% to 1.5 per year. So obviously your bones are going to age a lot faster than in space than here on Earth. NASA has also learned that behavioral issues among groups of people crammed in small spaces over a long time, no matter how well trained they are inevitable. So obviously, if you're in a small, little cramped up space, best way to put it is you're gonna lose your mind. The types of problems you may encounter are a decline in mood, moral or interpersonal interaction. You could also develop a sleep disorder because your circadian rhythm might be thrown off due to 38 extra minutes each day on Mars, or a small, noisy environment, or the stress of prolonged isolation and confinement. The most dangerous aspect of traveling to Mars is space radiation. On the space station, astronauts receive over 10 times the radiation than what's naturally occurring on Earth. Our planet's magnetic field and atmosphere protect us from the harsh cosmic radiation, but without that, they are more exposed to the treacherous radiation. Obviously, if you're going to go to space, you want to plan. So planning is it's key. Planning is key in space travel. How far away is Mars exactly? It's 140 million miles away from Earth on average. In contrast, the Moon is only 0.239 million miles away. With the communication delay of up to 20 minutes one way, while on Mars and the possibility of equipment failures, you must be able to complete the mission on your own. So basically, if you are traveling that far, the distance between communication is going to be a lot further than it was to the Moon. So how safe is it really? We don't really know because we haven't tried it. But according to what this is saying, you're basically going to be going in blind. Now let's talk about the budget. So the U.S. has a $450 million for the first unmanned Mars lander mission. It also has a $425 million for the communication satellite, $90 million for the first rover mission, $2,300 million for all remaining outpost hardware and supplies before the human mission, $1,250 million for sending the first crew to Mars, $582 million for operations including astronaut selection and training, $93 million for ground stations and other costs, $1,850 million per year for follow-up human missions. So you guys can see just how expensive it is to send humans up. Not even that, but just anything. So obviously sending rovers, is going to be a lot more cost efficient than sending humans. In 2005, NASA had a budget of $16.2 billion. This includes not only the human spaceflight division, but also other engineering projects and science funded by NASA. Total federal spending in 2005 was on the order of $2 trillion. But that was in 2005. Let's talk about today. NASA has a total budget about $17.6 billion. That doesn't just include human exploration, but absolutely everything NASA does. You guys can see a little bit of an increase. These expenses will only go up when considering long-term space travel, such as manned exploration to Mars or Jupiter's moons. While new technology may certainly limit the inefficient costs involved in space exploration, many argue that it is still money that could be better spent on pressing issues. So how important really is sending man up to Mars or doing all that stuff? The cost of manned space in both is the cost of manned space flight is much higher than the cost of robotic space flight. Space agencies can put robots into orbit at a fraction of the cost of putting humans into orbit. So like I said, sending rovers and stuff like that is going to be more cost efficient than sending humans. Not only that, but it also is less risky. If a robotic spacecraft blows up during launch, gets destroyed in orbit, or fails in some other fashion, is unfortunate setback. But that's all. If a human craft explodes, you're obviously dealing with tragedy, families upset, the press is upset, everyone's going to be upset. Despite its limited scopes, NASA's human spaceflight program gobbles up a huge portion of the agency's budget. $3 billion annually just to continue operating the ISS. So we did mention the ISS. But the vast majority of the science being done in space is achieved by robots that cost pennies on the dollar when compared to humans in space. If humans go up to Mars, they'll have no choice but to bring with them their microbes. For those who may not know what microbes are, it's just a microorganism that it's like leading bacteria and causes a lot of risk. So it could contaminate Mars. It is inevitable. For a start, there are more microbes in our body than in every body cell. And that's not even including the air we breathe in the crafts. In 1986, the Challenger shuttle disaster is a good example of our failure to do so. When the shuttle exploded 73 seconds after liftoff, it claimed the lives of 7 astronauts. And the mission was just to deploy a communication satellite on orbit and conduct other simple experiments on task, whereas a rover could have done the same thing. We're not learning anything significant by having astronauts living and working in space for extended periods of time. Instead, we're floating quietly in a microgravity, watching the sun rise and set 18 times per day, whirling around Earth at 27,000 kilometers per hour, and I'm sure none of that is nearly as good as it sounds. Today at NASA, there is no active long-term goal. The agency often reiterates that it's on a journey to Mars, but they've yet to lay out the detailed plan for how they're actually going to get there.